All right, Charles, you were about to say how we can do this.
I think the answer is simply that we basically need to flip the. Here's my thinking. We need to flip 0 and 1, which suggests that either our weight or our threshold needs to be negative. And since the threshold isn't above, it's going to end up being our weight being negative. So let's see. If we have a 0, we want to turn that into something above the threshold. And if it's a 1, we want it to be below the threshold. So why don't we make the weight -1?
Good.
And that will turn a 0 into a 0, and it'll turn a 1 into a -1.
All right.
And so then the threshold just has to be 0.
So that would mean that anything, I see. So anything that's negative will be greater than or zero or negative will be greater than or equal to the threshold. And anything on the other side of that would be under the threshold. So we get this kind of dividing line at 1. So we're taking advantage of the fact that the equation had a greater than or equal to in it. So
Right.
yeah, right, that ought to be a not. So we've got and, or, and not are all expressible as perceptron units. So and, or, and not are all expressible as perceptron units.
Hey, that's great, because if we have and, or, and not, then we can represent any Boolean function.
Well, do we know that? We know that if we combine them together, we combine these perceptron units together, can we express any any Boolean function that we want using a single perceptron?
So what do we normally do in this case? So what's the most evil function we can think of?
Yes, indeed. Well, when we were working on decision trees, the thing that was so evil was the XOR, or parity more generally. So,
Right.
all right. I mean, maybe if we can do that, we can do anything. So let's give it a shot.